Good day, everyone. I'm Brian, and later I will be joined by Unisse, both from the Center of Complexity and Emerging Technologies at De La Salle University, in presenting our most recent Viz project, RiesgoVis. RiesgoVis is a storytelling data visualization project that aims to share our insights about Marikina, the suitability of its many areas for flood evacuation, and an assessment of its current evacuation centers. As you go through the narrative, you can explore the supporting data through interactive maps so that people can toggle between the different data layers. We submitted this work as an entry for the 2019 Vis Risk Challenge that is sponsored by the Labs team of the Global Facility for Disaster Reduction and Recovery, hosted by the World Bank Group in partnership with Mapbox and the Data Visualization Society. We got to know about this competition from the Data Visualization Society, which is an international non-profit organization focused on data visualization, which Unisse and I are members of. In fact, with this data visualization entry, we won the grand prize and the Best Interaction Design Award from this competition. Now, there's a lot of pre-work done before we even started working on the RiesgoVis visualization. Most of it was part of an undergraduate thesis from the same research laboratory. Big thanks to Winfred, Benson, Darlene, and Tyler. Hello. Central to this work is the creation of a multi-criteria model for assessing the evacuation suitability of an area using various open datasets. The results of this data processing and analysis pipeline and the area level assessment from the model were all used in RiesgoVis. In creating the multi-criteria model, we divided Marikina into a fixed size grid and considered the following factors: the safety based on flood hazard maps from DOST NOAA, land use to identify commercial, residential, and open areas, accessibility based on the number of roads within an area, distance of an area to the nearest evacuation center, and the maximum number of people living within the safe distance from evacuation centers. Here is a quick view of the map visualizations of each dataset used. Concluding our narrative in RiesgoVis, we shared where are the ideal areas for evacuation in Marikina, which are the Ateneo campus, the area around Marikina Sports Center, and in Marikina Heights. At the same time, we also identified existing evacuation centers which are built in unsuitable areas for evacuation. We purposely designed RiesgoVis to use these insights and start a conversation on how we can prepare for the worst disasters. Now, Unisse will be sharing with you how we planned and developed the actual Viz.
Thank you, Brian. So as we were planning the visualization, we had a lot of considerations that we wanted to look into before we actually built the storytelling piece. So the first thing that we wanted to actually do was, we know that we wanted to tell a story, so we had to start with an outline. As any kind of storytelling would need, you need to start with an outline. So we started with where Marikina is. So we wanted to show where Marikina City is, and what is the demographic or the location, and also the geographic properties of Marikina City. Additionally, we wanted to tell the story that it has a river right in the middle of Marikina City, and when typhoons hit, what happens to Marikina. The next part was talking about the evacuation centers and how big the centers were, how many people can actually fit in the centers, and how many people can actually reach these evacuation centers by walking, and all of the other things. Lastly, we also included the piece wherein we had the suitability maps that were generated by the analysis that we did before. So, as mentioned earlier, we had a lot of data layers with our project. We had 3 flood hazard maps, which actually also generate 3 other suitability maps together with the other land elevation, land cover, the distance from their houses, like from each cell in towards the evacuation center, in terms of accessibility, how many roads are there in a node or in a grid, and then of course the population, and of course additionally the evacuation center or the points where the evacuation centers are. So all in all, we had 12 layers of data over the same geographic location. So the main challenges with working with overlapping data is that you have to think what are the data layers that you can actually put on top of each other. So the main challenge with our data is that um, the data layers had different data types and different data ranges, which would also represent like different color type, color coding, and also different color matching in terms of if it's discrete or continuous. So is it categorical or is it going to be a gradient color? So it was a bit challenging for us to actually choose what colors we would want for these data layers to show and which data layers we wanted to show together to be able to tell the story. So what we did was we actually combined and associated each of the data layer with the section of our story as part of the outline. So the outline actually had specific sections, and each section had a specific data associated to it. So that's how we were able to connect this towards the interactivity that when as we scroll through the story, we knew that we wanted people to see the data and play around and just try to explore what's there first before actually proceeding with the next chapter of the story. So that's why we allowed people to actually filter with what year they wanted to see for the flood hazard return period, and what evacuation centers they would actually want to see specifically and probably see in terms of risk, in terms of the flood hazard, or in terms of where is it situated in terms of height or elevation for the evacuation center. So when it came to building the application or the visualization, these are just some of the tools and techniques that we were able to do and use for our vids. So first is we worked with Mapbox, because as part of the challenge we had to also use Mapbox, and I actually enjoy using Mapbox because first you can design your own maps or your own base maps, and they have a generous free tier for you to work with, wherein you can actually host your own data sets there. You can upload GeoJSON files, and then it will turn them also into Mapbox tiles or vector tiles that you can load into a web visualization. So since we knew that we wanted it to be a web interactive visualization, we also used React.js. It's a front-end JavaScript framework. Mostly because I was already comfortable with developing using React, and I had different reusable components that I wanted to work with and configure. So it was mostly the story chapters connected to the data layers and also the legend. So which I'll be discussing more in the next few slides. So as mentioned, with Mapbox, we can actually design our base map. So this was the first thing that we did, other than designing or organizing our story. We changed the base map that was provided already by Mapbox, and we highlighted the Marikina River or the waterways that we had on the map and subdued everything else. So we made everything a bit more neutral and then just heightened the color of the water. This is so that it doesn't clash too much with the other colors that we were going to overlay on top of the map, so that it's more prominent for data rather than the background. Next was in terms of the tools and additional data processing that we had to do for our project. The original data came in an XYZ raster data format, so it was just the longitude and latitudes plus the value for each data layer for each 10 by 10 meter grid. But the challenge there was that the data files were a bit too large for it to be loaded into a web visualization. So we had to first convert the raster data into GeoJSON, which actually bloated up the file size a bit more. So we had to decide that we needed to make it more interactive and have a faster response time. So we aggregated the data up into 100 by 100 meters instead of 10 by 10. It When we were comparing the data, it did not really have a big issue because what we did was we just got the maximum value, or the value that had like the biggest or the most significant amount. So for example, in one grid there are 10 blocks that are high and then only one block that is medium or low. We would focus on the high so that it's actually overestimating rather than underestimating. Lastly, as mentioned earlier, we uploaded the GeoJSON files that were a bit bigger, and then we converted that using Mapbox into map vector tiles so that it was easier to work with the Mapbox GLJS, and also in terms of the file size, it was a bit smaller and it did not have. We didn't have to host it locally. It was all hosted on Mapbox, and we would just retrieve from Mapbox using their map API. So lastly, the reason why we used React in the first place was we wanted to have these reusable components for the legends and the interactivity pieces, which are the filtering toggles, the radio toggles for the map layers, and also the selection for the evacuation center types. So as you can see in the first two images here on top, we had different maps that had continuous values like the land elevation and the population. So that needed a different kind of color scale. But at the same time, we use the same element and the same positioning for the categorical variables, but we presented it in a different way. So putting it all together, this is our visualization. I'll show a demo in next. So this is our visualization storytelling piece. You can visit this website at comet.dlsu.edu.ph/riesgo, RIESGO-VIS, so that you can actually interact with it also. As you can see here, as you scroll through this story, you can interact with the map and it automatically changes the perspective, and also you can filter through this side navigation bar here. And as you scroll through the story, you can actually, it will also change the data that is presented on the slide. And then you can also basically toggle the different things to select and hide certain things. Additionally, each part of the story actually adds a little bit of data into the visualization. So as you see here from our ideal coverage, we only talk about the population coverage of the evacuation center. But as we scroll through here, we also add into the capacity of the story of the evacuation center, so that it adds onto the different pieces of the story. So it's mainly driven by the authors or us, wherein we let the readers interact with whatever we need them to interact with, and basically they still have the general freedom to play around with different details in the story. So as you can see, feel free to explore, and eventually at the very end we talk about the different good places of Marikina City in terms of how suitable they are for future evacuation centers, or for actually trying to find areas where it's safe for people to evacuate to. So that is it for RiesgoVis, assessing and visualizing evacuation suitability, from Brian and me, Unisse, Chua, both from the Center for Complexity and Emerging Technologies from De La Salle University. Thank you and have a good day.